Hi students, we're back with part 2 of lesson 5.5, which will be studying the ambiguous case. The ambiguous case shows up in the law of signs, and basically what it says is depending on the information that was given, it will create either 0, 1, or 2 triangles. And so we're going to continue to work with the law of signs, but we're going to add a level or layer in of helping you learn how do you know how many triangles are created. Now, I want to take the time to talk about this because there are times when students are trying to solve a triangle for the different triangle side lengths and angles, and they're getting error messages on their calculator. And the reason they're getting error messages is because there isn't a triangle that's possible, but they don't know that because they didn't know how to investigate it. So know that if when I'm explaining this, you're like, I will never be able to remember all of that, I encourage you to think logically. And I also encourage you to, if you get an error message, consider the fact that, hey, it could be one of these other scenarios that are happening. So let's jump right in. This particular scenario of getting different numbers of triangles is only going to happen when you're given a side, and an angle. Now, in the picture I have here for you, we have our side A, our side B, and our angle A. Now, as you move forward, I always draw my given triangle, no matter what letter, what angle measurement I was given, with that angle in this bottom corner, just because this is how I've learned to visualize it. And I encourage you to find ways to understand how to visualize it as well. But the reason why this combination becomes so tricky to work with is because depending on what this side A is, it could produce things or situations that just don't make as much sense. So, for example, if I drew in like this blue dotted line, that blue dotted line doesn't have to be long enough to touch this bottom base. And therefore, like when it's too short, it can't make a triangle. It's impossible. And so with that situation, we would need to be able to find the height of the triangle. Now, we learned how to find the height of the triangle in our understanding of the law of signs. Remember, we took sine of A equals H over B, and H was the height of the triangle. So anytime that value of H is greater than that side across from the angle, you're not going to get a triangle. That's your 0 triangle scenario. Okay. Now, the second scenario that can happen is we could end up having it equal H. In that case, we get 1 triangle. Side A could be longer than side B, and so now it just produces 1 triangle as well. But if side A is a little bit longer than H, but shorter than B, what happens is it swings across and it creates a second triangle right here. And that second triangle still has the same angle, still has B, and still has A. Remember, this is that A side that I swung across the shape. And so you see that it just maintains that. And so that's where these scenarios become a little bit tricky because we don't know what this bottom length is, and therefore it could be this short one or it could be this longer one. And so we have these scenarios all laid out for you here. The first scenario, obviously, it's too short. The side across from the angle. So you are given the pink angle, the pink side, and then the green side. And this first scenario that we have listed here, this is the situation where we have 0 triangles. So no triangles exist. On the second one, we have when that green side is the same as H. Here we're going to have 1 triangle. The one right below it is also a 1 triangle scenario. And the reason that's a 1 triangle is because when we swing that green side over, it overextends, so it doesn't keep everything the same. And it doesn't produce your triangle. So therefore, only 1 triangle is created there. And then obviously we have our 2 triangle scenario where it swings over and it creates one big triangle on the outside. And I'm going to try to highlight that. So there's your one triangle is in red. And then your secondary triangle, I'll go ahead and draw in orange. See if that shows up, is this little slice over here. Again, both triangles have the same given information, but are slightly different. Now, again, this is all dependent on you being able to find that H value. So just recall that the H value is going to be found by taking your angle, your sine of the angle, times the side that is next to it. So this would be your angle right here, and this would be the side you're multiplying by, and that's going to give you this H value, which will allow you to determine which of the scenarios makes the most sense. All right, so let's move on. I've created this little table to help students recognize the different scenarios. So again, in my triangle up top, I have your ability to calculate H. I also have the given information. So this is your side angle that was given. And these are the rules we just discussed. So when this A side is smaller than H, it's too short. When the A side is equal to H, you get one triangle. If A is larger than B, you're going to get you get one triangle. Apologize. And when A is smaller than B, but bigger than H, that's when that two triangle scenario occurs. All right, so let's go ahead and move into practicing using these strategies. So the first example I have, I'm asking you to find the missing parts. Again, we know that it's more of a tedious process than it is difficult, but the difficulty is actually in determining the number of triangles that exist. So the first thing that I notice in this particular setup is that the side across from my angle this side is larger than this side. So right off the bat, I'm saying, hey, this is probably going to be a one triangle scenario, but let's just make sure that this is long enough. So we're going to go ahead and do the analysis with finding the H value. But right now I am seeing that this is resembling this scenario right here. So to find the height of this triangle, I would just go ahead and take 8 times sine of 52 degrees and type that into your calculator. When I went ahead and calculated the H value here, I got 6.32. So that's perfect. 6.32 is shorter than 10 or smaller than 10. So therefore, we're good to go. This is a one triangle scenario. All right, so we have our one triangle scenario, and I'm going to solve for side B because that's the only, or angle B, because that's the only angle that is available for me to solve for. And in doing so, I again look for the angle across from the side. So we have 52 degrees and 10. That is my setup for my first proportion. And that equals sine of angle B over 8. Now this is a little bit different in our solving because we do have an angle that we're finding. So the first thing we're going to do is we're going to multiply both sides by 8 to isolate the sine of B. And then what we need to do is we need to get rid of the sign. We need to isolate the value of B. Now, I could definitely type this into my calculator, but I'm choosing not to because I want to wait and type it in all at the same time. So next, to get rid of that sign, we need to do sine inverse. So remember, we did learn about inverse sine or inverse trig earlier, and basically what that's doing is it's getting rid of the ratio and going to leave you with your angle measurement. So now we're ready to actually identify what is angle B. And to do this, I'm going to go ahead and grab my calculator, clear my screen, and start the work. So to type this in, you can go ahead and type it all in one fell swoop. So we sine inverse, and then we have 8 times the sine of 52 degrees. Notice I closed my parenthesis on the sine of 52, and then I'm dividing it by 10. When I do my math, I get 39.08. So we'll keep our degrees to whole degrees unless it's stated otherwise. So I'm going to say this is a 39-degree angle. All right, so we now have angle B, and that is 39 degrees. All right, so I'm going to label that in my triangle just to help me track with the different parts. Next, most people will go ahead and find our angle measurement. Our angle C measurement is going to be that 180. So we have 180 minus 52 minus 39. And when I did that math, I got angle C to be 89 degrees. And now we're ready to do the final side, and that's side length C, little c. So we'll set it up with our core or given ratio, which is sine of 52 over 10 equals sine of 89 over C. Multiplying by C and 10 are cross multiplying. And then dividing by your sine of 52. Now it's time to pick up the calculator and do the calculations. So little c ends up equaling, when I typed it into my calculator, I got 12.69. There you go. We solved one. Now, the one thing I will say is the only time that these ambiguous case questions come up is when you're specifically given a side-side angle in that order. Notice the sides are in order, they're next to each other, and the angle follows it. Every other case, you'll be able to use your other law of sines properties or potentially your law of cosines, which we haven't learned yet. All right, I have another problem for us. So in example 4, they gave us this information. I have a triangle already created for us. And again, I don't care as much about the letters. I'm always going to place my given angle in that bottom corner. It just is how I visualize the problems. It really helps me. That makes this 6, and then side A is 7, which makes this angle A, and this B, and this is B, this is C up here. All right, so now we have our triangle labeled, and we are going to go ahead and start working with figuring out what's going on. So anytime I see that the side across from my given angle is smaller than the other side given or the adjacent side, it starts to make me think, hey, this is a situation where that 2 triangle could show up. So I'm going to go ahead and find the h value, because it's important to know that this side is long enough, because sometimes that side just isn't even long enough to create the triangle. So to find h, I'm going to take 7 times sine of 26 degrees. And when I did this, I got 3.07. So that means the height is shorter than this, and it confirms my suspicion. This is a 2 triangle scenario. So what's happening is we have this outside triangle, but then we're also going to have a secondary triangle that is created. Now, I'm going to go ahead and start by focusing on the first core triangle first, the one we see as it's drawn, and then we'll talk about how do you find that other triangle after that. So to begin, I noticed that my side and angle relationship that we will work with or focus on is here. Remember, that's going to be included in all of my calculations. So I have sine of 26 divided by 6 equals sine of angle A divided by 7. Multiplying by 7 on both sides gets rid of that. And then to get rid of the sine, we use sine inverse. All right, so I'm going to do that sine inverse. And now I can go to the calculator and typing that in. I'm going to go ahead and demonstrate that again on this problem, as I know that's kind of a new concept for some of us. So we go second sine, and then we have 7 times the sine, regular sine, of 26 degrees, close the parenthesis, divided by 6, close the outside parenthesis. Hitting enter, I got 30.75 degrees, so I'm going to round that to 31 degrees. So moving back into my problem, I'm going to go ahead and state that angle A is 31 degrees. All right. Next, I'm going to find angle C. So angle C, again, not a super scary thing to have to find. 180 minus 26 minus 31. And I get that angle C is 123 degrees. All right. And then our last part of this is going to be to find side C. So side C is going to be found by taking, let's go ahead and do that right over here. We have sine of our 26 degrees over 6 equals sine of 123 degrees over little c. Doing our cross multiplying, c sine of 26 equals 6 sine of 123. Dividing by sine of 26. C is going to equal 11.48. All right, so we found all of the information for our first triangle. Now what I'm going to do is I want to actually take and we need to use part of this triangle to do our calculations for the next part. And so I'm going to go ahead and just sketch another triangle for us to reference. Again, being able to have that referencing piece is really important. So I'm just going to kind of try to sketch it out the best I can so it looks similar to what's going on above. Right, not terrible. And again, I'm going to relabel this new triangle that we've just drawn. So we know that this is 26, and this is 6, and this is 7. Now, what's actually happening with this triangle is this side length of 6 is essentially going to swing. And what I mean by that is it's going to swing, and in its swinging, it lands before it would cross that bottom line. So what we've created, and I'm trying to keep it as precise as I can, is we've created this new triangle. Now, the new triangle we're actually trying to solve for, and again, I find that this is the hard part to visualize, is this triangle right here. So this blue highlighted triangle is the triangle we're trying to solve for when I just highlighted. And what's going on is when we swung this side over, this side is 6, which means we created an isosceles triangle that we're not solving for. But in this other isosceles triangle, we knew that this was 31 degrees down here, which means this bottom angle over here is also 31 degrees. And because we know that that angle is 31 degrees, we can now find the other missing angle, which is right here. So I'm just going to go ahead, and now that you see what I'm talking about there, again, I'm going to draw out that triangle we're working with. just a little bit bigger because it's hard to see right now. So this is that outside side. This is the short side. And then this is that. So that's that blue triangle that I sketched there. And in this blue triangle, we know this bottom angle right here is 26 degrees. We know that this side is 7. We know that this side is 6. But we also have the ability to find this angle right here. And the reason we have the ability to find this angle right here is because we know that this other side of this triangle has an angle measurement of 31 degrees. And so with that in mind, I can find that measurement by saying 180 minus 31 degrees. And when I do that, I get 149 degrees. Now you might say, wow, that's a very large obtuse angle. It absolutely is. But notice that it does work out to find this top angle now, because that would be 180 minus 149 minus 26. So again, I'm looking at those core angles on the inside edges. And when you do that, this top angle is always going to be relatively small. In this case, that's a 5-degree angle up there. And now that you know that top angle is 5 degrees, we can set up our proportion and solve for our little c, which is right down here. So we would have sine of 26 over 6. Again, that's my core proportion we started off with. And then we would have sine of 5 degrees over little c. And finishing solving, we have c sine of 26 equals 6 sine of 5, dividing by sine of 26. C equals a very small side length of 1.19. All right, ambiguous case. It's a lot. I encourage you to pause, go back, think about it, visualize it. It's not going to be something that's super easy to come to mind with and kind of wrap your brain around, but it's really important that you start to kind of think about this. Now, here's the catch. If you think it's an ambiguous case and it has two triangles and you try to solve for it, but it doesn't work, you can always catch yourself, because the secondary triangle will not add up to 180 degrees. So you could always just check everyone, but being able to recognize it would be better. Have a great day.